So, hello everyone, and welcome to our third webinar on citizen science. And today we have a new host of speakers for you, and we have Stella Kafka, who's going to start off, and followed by six more citizen scientists from the country who'll talk about their work. So, welcome Stella, and welcome everyone. And so, Stella is Dr. Stella Kafka is actually the director of the one sec, just a minute. Yeah. So, Dr. Stella Kafka is the director of the American Association of Variable Star Astronomers. She holds a PhD in astronomy from Indiana University. And before her tenure at the AAVSO, she held positions at the CTIO, at the Spitzer Science Center, at Carnegie Institute of Washington, DTM, and AIP Publishing. The AAVSO is an international nonprofit organization of variable stars observers whose mission is to enable anyone, anywhere, to participate in scientific activity through variable star astronomy. So welcome, Stella, and we all look forward to hearing from you about the AAVSO and their activities. Thanks.
Thank you very much, Priya, and it's actually a great pleasure to be here. This presentation is on behalf of our ambassador, Teja, who is there. I wanted him to actually introduce the AAVSO, but I insisted I join him. So as was mentioned, I am the Executive Director and CEO of the American Association of Variable Star Observers, an organization that started 110 years ago out of Harvard College Observatory to coordinate variable star observations for the then observatory director, Edward Pickering. As such, in principle, the AAVSO was the first association that was founded exactly in order to connect professional and amateur astronomers and help them collaborate on scientific projects. We are the original citizen science organization. Since then, we have grown. We have more than 7,000 individuals in our rosters, both professional and non-professional astronomers who are interested in understanding some of the most dynamic phenomena in the universe. This is our mission. As was mentioned, our mission is to enable anyone, anywhere to participate in scientific discovery through variable star astronomy. And there's some words there that highlight who we are and what we're doing. Enable means that we provide necessary resources and equal opportunities to all. Anyone, those opportunities are provided to individuals independent of their socioeconomic background, the professional preparation, educational background, etc. Anywhere, you should be able to access our resources no matter where you are on this planet and participate. That's actually my favorite word. Be actively engaged with the AAVSO in various ways. So as you understand, we are, as we're truly international, we have a very diverse community. This translates to serving people with different needs, different priorities, different professional preparation, different habits and cultural backgrounds, who are all united under the international umbrella of astronomy. Please remember, astronomy has no borders. The night sky has no borders. So we work with individuals who are interested in using variable star data for research projects. We work with the educators who introduce astronomy to their students. We collaborate with a very dedicated group of volunteers. We communicate with individuals who are just interested in learning more about new discoveries and progress on variable star research. People who actively support citizen science, believe in our mission, but they're not necessarily interested in doing astronomy themselves. And of course, we work with our observers, individuals who acquire data through their telescopes, CCDs, DSLR cameras, or even through their binoculars, just looking at the night sky, and share this information with the wider community through the AAVSO International Database. At the very core of our program is variable stars. And to be on the same page with everyone, especially with those of you who are not exactly, have not been exposed to variable star astronomy, variable stars are stars whose brightness is changing with time, within timescales that we can measure, with respect to stars that exist in their vicinity, but do not change with time. And this is my favorite example. This is what we call a globular cluster, M3. You can see the center of the cluster here. It's a family of stars that were born at the same time with different masses, so it evolved in a different way. At the center, it's very dense, and the density kind of getting diluted when you go outward in the cluster. And this is pretty much a movie that is the result of a collage of 4 different images. Someone went out and took one picture after the other 4 times, and they created a movie just circulating among those 4 images. And if you just look at the picture, it's gorgeous, very sharp. Most stars are just not doing anything there, just sitting there. But if you pay very close attention here, you will see that there's some stars that are blinking. They're changing in brightness. Can you find the variables? And if we had more time, I would actually have a competition. How many variable stars can you find in 30 seconds, right? So just identify and measure them. These are the variable stars. This is what I mean by stellar variability. Stars whose brightness is changing every time we observe them. And then there are other stars that are not changing at all. So this is, now, you're looking at the stars. All you see is dots that are changing. Like they're blinking back and forth. How do I know? How do I get information out of that? How do I know what kind of science I'm getting out of that? What kind of stars they are? They don't exactly come with labels. They don't exactly send us signals telling us, oh, I am this type of variable versus another one. The way that we do it is we measure the brightness of each star, both the variable and the non-variable, from every image. We compare them, and the difference is what we call a light curve. So we plot the brightness of the variable star with respect to the brightness of the non-variable star with time. It's like, you take each image, and each snapshot in time represents one image. But here's your non-variable star. It's not doing anything. Here's your variable star. It's doing things. Again, brightness difference with time. And based on the shape of this graph, which we call light curve, we assess what type of variable star we have. What is the nature of variability? Why this brightness is changing? What is the physical mechanism behind this change in brightness? So there is a zoo of variable stars out there, and we know about them because of the light curves. Here is just an example of, again, light curves, or a collage of examples of light curves and variable stars. We have eclipsing binary star systems, or 2 stars, where one is passing in front, behind of its companion, and it's stealing the light. So we see a drop in the brightness. This is a technique that has been used for a long time to actually detect exoplanet transit. So when you have an exoplanet that is passing in front of its parent star, its host star, you see the brightness of the star falling. We have spotted variables. The sun is a variable star. And as it rotates and it has big sunspots, the sun, right? As it rotates, it has a modulation in its light curve, a modulation in its brightness, a change in the brightness, something that we see with other stars as well. We have stars that pulsate, literally increasing and decreasing their brightness, their size, for reasons that are known, but that actually increase and decrease in size. Compression and expansion of the atmosphere of the star has a very characteristic shape in the light curve. We have stars that explode. I'm pretty sure you've heard about supernovae, which are violent deaths of stars at the very, very end of their lives. And they have a very characteristic increase in the brightness, and then a soft decrease as the star completely disappears. We have what we call cataclysmic variables, stars that cannibalize each other, where you have a white dwarf that is eating up, literally eating out the other atmosphere of its companion. Occasionally it has burps or bursts or outbursts. And I'm pretty sure you've heard about nova outbursts, which are very, again, characteristic in the light curve. They do not destroy the system. So occasionally we see more than one nova outburst. This is a low mass X-ray binary. There's a black hole that is eating its companion. Occasionally it has outbursts that we can actually see in light curves. And this is just an example. There's so many other examples that I could share. I mean, I could just spend all day telling you about variable stars. We have gamma ray bursts of protostars, irregular variables, the sun, and we learn about them by building light curves. That's our tool, and this is what we do here at the AAVSO. So I guess what I'm trying to say here is that if you're interested, if you can actually take astronomical data any way you can, actually even with your binoculars, you can look at the variable star of interest and a comparison star and build a light curve. If you can build light curves, if you're interested, you can definitely acquire data and be part of scientific discovery through the AAVSO. And we are here to provide you with the resources that you need in order to get started and continue with your journey. We build communities of individuals who work on projects, professional and non-professional astronomers, and we all have a place in the research arena. So how can we help you? First, we are pointing to you stars of interest. I mean, there are million stars in the night sky. There are billion stars that you can actually observe. How do you know which ones are the interesting variables, right? So there are two different ways that we are doing that. The first one is through our alerts and campaigns. These are requests for observations of specific stars coming mostly from professional astronomers. So someone has, for example, time to observe an interesting cataclysmic variable, a nova in this example, right? With the Hubble Space Telescope, the Chandra X-ray telescope. But, you know, at the same time, they don't really know what the star is going to be doing photometrically, because all they have in their hands is like this 1 or 2 points that the Hubble is going to give them or Chandra is going to give them. They need a light curve. So they come to us in advance and they ask for that particular star to be observed. And what we do is we send an alert to our observer community. Right now, we have more than 2,000 subscribers in our alert system. So someone will definitely observe. So our observer community is observing that object from the ground, while the Hubble Space Telescope, the Chandra, or actually sometimes TESS, we're doing TESS follow-up now, TESS or hopefully James Webb, when it comes online, will observe the star from space. So we have a lot of opportunities for our observers to get their hands dirty alongside professional astronomers for very specific projects. Of course, you are researchers yourselves. You can actually do whatever you want. If you want to pursue your own observing schedule, observing program. So we are providing what we call a targets tool. It is an infrastructure that allows observers to build their own observing program. So what you get through this tool is information of interesting variable stars, their right ascension, declination, constellation. You get information on their minimum and their maximum brightness. Remember, these are variables, right? So they don't have one magnitude, they don't have one brightness, they have a range. You get information on how we want or how we need those stars to be observed. You have information on what we call a cadence, how frequently we need data on those stars. Now, mind you, this is a guideline. You can just observe one star all night long if you want to. You can observe one star for 2 hours and that's it. Or you can actually build your observing schedule with a list of stars that you can go from, and you can go from one star to another throughout the night. It's completely up to you. All those things are recommendations, nothing else. So we also offer information when the target is observed last, so whether it needs observations. And we have a flag where we are requesting observations on stars that are not being observed very frequently. So for example, the flag is red when a star doesn't have a lot of data. Once somebody submits the data on this particular star, the flag moves and becomes green. Black is a flag that showcases that particular star is behind the sun, so it's not available at that particular time of the year for you. And we have all kinds of notes. Some of those targets are parts of our alerts. So for that, you see a little triangle, a little symbol that is giving you the opportunity to participate in that particular project. Each line here is sortable. You can sort it. So you can get stars of only alerts if you want to, stars of a specific brightness range, et cetera, et cetera. And if you register in this tool, which is free, you don't have to be a member, just register here. You can select, based on the location of your observatory, you will see only targets that are visible to you. So you don't get to try to figure out whether a target is northern hemisphere or southern hemisphere. Can you see it from your location or not? So this is giving you the opportunity to build to build your own program. You can actually even select based on the type of variables. That if you want to do only cataclysmic variables, only alerts and campaigns, if you want to do only exoplanet transits or only pulsating variables, you can just select up here what you want, and that is going to be the list that you're getting. Not only that, we're also providing practical tools that facilitate our observations. So we're providing charts, finding charts and appropriate comparison stars for each field in the sky based on your equipment. So if you have a CCD camera or DSLR camera, if you have binoculars, you can actually select the appropriate finding chart so that you know where to look, right? You know exactly how the field looks like. We provide tools for data uploads and data downloads for professional or non-professional astronomers. We have a lot of, actually, we have a lot of citizen scientists who are doing research just by using data in our databases. We provide tools to you to visualize your data. This is what we call a light curve generator, which plots the data of your star. Once you submit them in the database, plot the data of your star alongside data of other observers. This is a light curve. And actually, the reason why I chose this particular star, it's a pulsating variable, is because I have submitted some visual data for this particular star. So somewhere here, there are a couple of points that I have taken myself. And I just use my binoculars. I don't have any fancy camera or fancy telescope. And of course, we have our super catalog, variable star index or VSX, which is providing information on variable stars. It includes the known information of more than 2 million variable objects. And actually, if you discover a new variable star, and yes, there's always opportunity for discovery, you can list it here and get credit for your discovery. We also provide tools for software to help you analyze your data. If you're using digital data, CCD, or I think DSLR camera is also included in there, you can use VFOT, where you just put your data in there and it gives you light curves. It's like in and out. It's very, very simple. It is a member benefit, so you don't have access to that if you're not a member, but there's so much software out there. You can actually use it yourself if you want to. And this is VStar. This allows you to upload your light curve in that particular graphic environment from your computer. So you don't really need to submit the data to the AAVSO before you upload it. And also it allows you to upload the existing data on that star alongside yours so that you can compare it, you can analyze it, and actually if you have data from another source and you want to use it for your research, you can upload it there as well. And this particular software allows you to do an analysis of the light curve. You can do fits, you can do periodograms, you can do all kinds of things that you would need to do in order to extract the result. So you can do your own research. That's the bottom line here. Now, one of the things that we are providing is all kinds of educational and training material. We recognize that different people learn different ways. So for some, our manuals are useful. So we have manuals that tell you more details that you want to know of different types of observations, from solar observations, how to safely observe the sun and acquire solar data, CCD, DSLR, visual, exoplanets, everything is in there. We have what we call choice courses. So these are our online courses. They last for 4 weeks. They're intense. They're based on our forums or discussion forums. So this way you can take them at your leisure. So you don't have to be in front of a screen. And that is actually facilitating individuals from all over the world to take those courses. We have a very active peer mentoring program. For me, when I started my own binoculars, I am a professional astronomer. I'm used to going to a telescope and have this fancy, expensive equipment and big telescopes that I'm not allowed to touch and give my target list to someone else to do the work. So when I started to do my own binocular observing, I wasn't sure how to find my targets. I had to actually try to see where the star of my interest is in the night sky. you know? So I had a mentor who was very kind to stand right next to me with their binoculars and just guiding me, star hopping, to go and find the star of my interest. For my learning style, this was perfect. I really, really liked it. So take advantage of our peer mentoring program as well. We also have a journal. Now, here's the thing. For professional astronomers, publishing their work is extremely important. This is part of who we are, what we're doing, right? It's part of our credentials, part of our requirements as a researcher, etc. But just think of you doing research and finding one good new result, one solid result, a periodicity, or correct a period of a star, or find that the star is a different type than the one that is cataloged. You need to actually report that, because if you don't report that, no one else will know what you have discovered. And if they need your result, then they will have to do the research again from the very beginning, get to your result, and then continue with theirs. The way that science progresses is when we're sharing the outcomes of our research. And this journal is exactly that avenue for you to submit one correct result. If you have a lot of information, you can actually write a huge paper, just send it somewhere else. But this one is for everyone to submit the outcome of their research. And actually, even for professional astronomers, most of us have so many small results and we don't know where to publish or what to do with them. And they're just sitting in our computer's black hole of unpublished data, and they're just doing nothing. They're doing pretty much nothing to anyone. So this particular journal publishes research articles, variable star researches, instrumentation and methods. We also publish some education and outreach, solar astronomy, definitely spectroscopy, exoplanets. We have some history and biographies, and actually for graduate students, some summaries of their PhD thesis. It is what we call double-blind refereed. So you don't know who the reviewer of your manuscript is, but the reviewer of your manuscript doesn't know who you are. So you can be a professor at a big university, you can be a person who's just a gardener or a nurse. Oh my gosh, I love actually nurses because they're the most useful people on the planet. Or an engineer, or anything pretty much. And the reviewer who is actually looking at your manuscript will just look at the quality of your paper. They don't know who you are. And they shouldn't, actually, right? If you think about it, we're judging good science. There's a template for authors. So you can just download a Microsoft Word template and edit it. So it doesn't require any special software, something that you already have on your computer. It is what we call open access. So it's your result, once it's published, it's available to everyone right away. So if they need it, they're going to use it right away. And also it appears on NASA's ADS system, so it is discoverable alongside other manuscripts. So just think about this as a way for you to share the results of your research with the general community. Now, I mentioned that we have a big photometry database. This is pretty much a database of variable star photometric observations. We also have an exoplanet database that is relatively new, that is meant to get long-term light curves of select number of exoplanet transits to improve ephemerides, for different reasons. And actually right now we have an alert, we have a campaign going on of a researcher who asked for observations, continuous observations, or as continuous as we can, of an exoplanet transit that is scheduled to be observed with the James Webb Telescope. So James Webb Telescope has not launched yet, and we're all biting our nails for its success because it's a huge, very, very expensive project. But individuals already started asking for monitoring data, for continuous data from our community for the targets that they already have guaranteed time on the James Webb Telescope. So one of these exoplanets it's one of the first targets actually for James Webb. I'm really excited to be part of this. Also, we have a community that is doing very active spectroscopic observation of stars. If you have a diffraction grating, a star analyzer, if you're interested in looking at stars with different goggles, this is another way of doing it. It provides different kind of information on different variable stars. We can talk about spectroscopy at a different time, perhaps, but just letting you know, for those of you who know what spectroscopy is and you're interested in it, this is another resource that we have for you. Now, you can learn more about all types of variable stars and groups the AAVSO is reaching out to through our observing sections. There is information, we have 12 observing sections right now. Each one represents a different category of variable stars, but also we have observing sections on spectroscopy itself. So the technique, the targets, the how-to, on instrumentation and equipment. If you want to get started, or if you already have a telescope and some kind of camera, but you're not sure what kind of filters to use, or you're not even sure about your setting, you can actually ask questions through this observing section. I would advise you to just browse and take a look at those. For variable stars themselves, pulsating, eclipsing, et cetera, these observing sections are giving you information on what the stars are. Right? What are they? Right? What is the physics behind them? How do the light curve look like? How frequently should I observe them? Should I observe them? I have this kind of equipment. Is this enough to observe those stars? And what kind of research is being conducted with the data? So these are things that you can definitely either find through the observing sections or ask someone in the observing sections. Each observing section has what we call a forum. So we have discussion forums at the AAVSO, which are for us an essential way for the international community to communicate and interact. This is a way of exchanging ideas, share information, ask questions. There's no such a thing as a simple question. Ask whatever you need to know, either for an alert or a campaign, for a type of variable star, a general or how to get started. If you're an educator and you're interested in getting astronomy in your classroom, variable star astronomy to your students, ask a question there. We discuss science results. We discuss specific stars to be observed, instruments, and lots of people who are actually asking instrumentation questions through the forums. There's always going to be someone to answer. And you know something, we don't have all the expertise at headquarters at the AAVSO. Our community will actually give you more information that we could ever give you. And again, every observing section has a forum here. And as an example, I'm using the exoplanet forum that has all kinds of discussion topics there. Last but not least, we have what we call webinars, online events, how-to hours. In 2021, they were on Saturdays at 2 p.m. 2022 will be on Saturdays again at 2 p.m. Eastern time, our time, local time here. Now, they're all recorded. They're all on our YouTube channel. So if it's, I think it would be the middle of the night for you guys, then you can just go back and watch them. There's so many subjects. Our webinars are more of a science presentations. Our how-to hours address really practical aspects of observing. So for example, you just bought a new camera, and now what? What do you do with it? So it takes you from zero to let's start playing with it. And of course, you can recommend, you can send us an email and recommend your own topics that you would be interested in finding out more about. So this is for our webinars and online events. This is a project that we launched last year, and it's going to keep going. This is more of a general outreach tool. It's a general outreach resource for those who are doing sidewalk astronomy and they want to introduce, or even planetarium shows. This actually was meant for planetaria. And they wanted to introduce astronomy to a much more general public. So what this shows is that for every month of the year, there is one constellation that is highlighted, the constellation that is right on top of your head. And within that constellation, we highlight one variable star, one interesting star. So for example, Orion, which is a constellation for February, we highlight Betelgeuse, which is a very interesting variable star that's causing all kinds of trouble lately. This is our way of introducing the concept of variable star to a general public, people who just have no idea that, you know, there is a whole world out there that is changing with time and you can observe it. All this information and even more is on our webpage. You just, if you're a beginner, you can find resources here. And here's our main webpage. Here's how you're getting our observing sections, education material, tools for observers, the journal, VSX, light curves, et cetera, et cetera. Everything is on our webpage. With that, I would like to invite you to the journey of exploring the universe. I hope I managed to convince you to try your hand in variable star astronomy and join us in our quest to explore some of the craziest objects in the night sky. As I mentioned, the AAVSO is a collaboration, professional and non-professional astronomers. We don't really care. It's that we're all working together, and that is the beauty of the community. This is, again, our webpage. I would like you to become a member if you can, or if you would like. And actually, it's $25 a year for India. So I should have connected that. But even if you don't want to be a member, everything that you see there is free. So a membership supports our work because we are a not-for-profit organization. This is the email I was mentioning, aavso@aavso.org. If you have questions, doubts, requests, anything, please send an email to this address and someone will definitely answer for you. And with that, I would like to thank you for your attention and ask if there are questions for me. And clear skies, everyone.
Thanks so much, Stella. Thanks a lot. So, questions. So I already see there's a question, which is a very interesting one. It's Sovan Acharya asking, I want to encourage citizen science projects for blind people or deaf and dumb people. Is there any scope for that in AAVSO?
We don't have that at the AAVSO. However, I know that there are other organizations that are making serious efforts on building infrastructure. Our friend Wanda has a software. So we've been working with Wanda. There are individuals who are making serious efforts to sonify data, because we know that individuals who whose vision is not very sharp has sharper other senses, so they can listen and they can actually distinguish special aspects of light curves of data that our eye sometimes misses, and sometimes even software misses. I'm still waiting for updates. Otherwise, we're very, very open to the concept of hosting a database like that, or a tool like that. We have more than 30,000 light curves in our database. They're not analyzed. I mean, even if you don't want to take data right now, there's data there for you to work on. So I'm really hoping that that's going to be incorporated eventually in our schedule.
Yeah, thanks. I fully agree. It is a time that everybody contributes. And like you said, there could be things that we ourselves do not notice, the so-called able people, right?
Oh yeah, I'm pretty sure able people. Come on, I'm wearing four eyes, and sometimes I can't see very well. So it's yeah, you're absolutely right, Priya.
So there's another question by Amritanshu. Are there methods to retrieve spectroscopic data for cataclysmic variable stars and online?
Could you please repeat? Other methods than online?
Spectroscopic data for cataclysmic variable stars.
If you want to retrieve spectroscopic data, our database has 8,000 spectra right now, and it's growing exponentially, and they're all validated. One of the things that I need to mention is one of the focal points here at headquarters is validating data, making sure that all data are of the quality that is needed for research. And if we find, and find discrepant data has nothing to do with observers' experience levels. Seriously, sometimes there are glitches in software for the most experienced observers, and they submit data that make no sense. All we're doing with that is contact the observer and help them understand what is the source of discrepancy. And this is a way of helping our observers become better at what they're doing. So we do have a spectroscopic database that has a lot of data on novae right now and cataclysmic variables. So it's open to everyone. You can just download the spectra on your computer and play with them.
Mhm. Thanks. But we have a great this thing from Bonnie Thurber, who actually says that glass, GLAS, has this for blind people. So Bonnie, you could add if you wish.
Definitely can look into it, yes.
Yeah. Amoli says, where can I find the step-by-step information to submit variable star data?
You can find them in our manuals.
Okay.
Our manuals explain webhooks. And if you have questions, again, if you have questions, send us an email. Just an email. I have variable star data. How do I submit? And someone will actually get back to you.
Mm-hmm. Yeah, so Bonnie adds that glass is actually located near Yerkes Observatory. And
Mm-hmm.
whatever, it's this thing. There are a whole lot of people thanking you for a lovely talk. I'm not mentioning them. Anayat asks, how much space, ma'am, in M cubes? Anayat, could you I'm not sure about the
Clarification,
question.
please.
How much is there in M cubes? What does he mean? Anayat, could you this thing, or maybe you could clarify? Uh, Amit Raka writes, we mostly completed a journal paper on astronomy, yet not disclosed this thing on moon eclipse. Okay, fine. And okay, Arvind Raja asks, as an astronomy beginner, I'm very interested in taking sun and sunspot photography. How can I further continue my research about sun and sunspots?
So the AAVSO has been curating what we call the American Sunspot Index, which is not American anymore because it's international, but it started during World War II. Up to that point, there was what we were calling the European Sunspot Index. But guess what? Europe was really busy during World War II and no one was doing anything with the sun. So we started our parallel program here at the AAVSO. This sunspot index pretty much shows or corresponds to number of spots on the sun. And this traces the solar cycle. And we continue this work, although there's so many space telescopes and ground-based telescopes, simply because we're using that data set to back calibrate the behavior of the sun. So we need to keep taking data with the same method in order to know what the sun is doing now with respect to what it was doing 100 years ago. So you can definitely take sunspot data. They're extremely useful. They're being used, I know at least by the National Solar Observatories here in the US for research purposes. Please join the solar observing section. We have a group of individuals that are extremely dedicated to taking data. And what impressed me is that I remember 2019, 2020, when the sun went through a very kind of bizarre minimum, it had no spots. We were getting data every day, every single day. 0 is a number. So that kind of dedication of looking at nothing is something that I highly admire. So we do have a very precious data set on the sun during that particular minimum. That was really impressive. And now that the sun's going towards a maximum, it's even more fun to observe. So yes, if you have a telescope with a solar filter, a specific filter, or you can take solar observations in a safe way, there's a place for you at the AAVSO and definitely for your data.
Yeah. We have a young girl, Mihika, who's in school. So what would you say would be the minimum age for school children to involve themselves in AAVSO activities?
Well, I'm going to defer that question to Teja because he's our youngest ambassadors. He's our youngest ambassador. You have a person who knows well here. Pretty much there's no minimum age in principle, as long as you understand what you're doing. So at some point you have to look at if you're a parent and you want to get your child involved in this particular activity, you have to look at their education level or their understanding level, etc. You can always tell them that there are stars who are changing brightness in the night sky, and just trigger this kind of curiosity and what's happening there. How do we know? Where do this variability come from? Why should we care? What is the the use of variable stars in astronomy. And that's a completely different presentation. And just as a preview, we're measuring distances in the universe, ages in the universe, masses, temperatures, magnetic fields through variable stars, and all kinds of life through variability. So I'd say before you get into trying to get young individuals to observing variable stars, get them to understand them first, and then they'll get there.
Okay. So thanks so much. So I see a few other questions, but essentially most of them I think they need to go to the website because there are people asking how to become members and whatever.
Everything on the webpage. And if you're an educator and you want projects for your students, we have a dedicated webpage about that as well.
Yeah. So I would suggest everybody just have a look at the website, and that should answer a lot of your questions. But in case there's still questions, you can always get back to us and ask or write to AAVSO, right? So
Absolutely.
Thanks so much, Stella. I see another message. Okay. Oh, this is this thing.
There's so many questions.
This one is about can you shed some time over Seifert variables and how distances are measured? I think that's a whole story.
It's a different.
It's
a different discussion.
Yeah, so we'll leave that for another time. And I think we'll end this with this because there are still many questions pouring in. One is the universe infinite.
Oh God, that's a Nobel Prize winning question.
Yes. So thanks a lot, and thanks so much, Stella, for being with us. It was really so nice having you.
Thank you for having me. Good to see you again, Priya, and good luck with the rest of the presentations today. And actually, congratulations for having this session. It's really very important for citizens to understand that they have a very meaningful contribution to make in science. You don't need a professional degree in astronomy in order to have a discovery, be part of collaboration, and be part of research. So This is wonderful. It's a great initiative.
So thanks.
And we're here to help.
Yeah. And see you. Bye-bye.
See you around. Yeah. Bye.
So we'll continue our session today now with a presentation by one of our youngest members, or I think he is the youngest member, Teja Begari. Teja Begari is in school. He's in the 10th standard in grade 10, and he's a junior astronomer recognized by the Indian Book World of Records, and he's by the India Book of Records for the contribution to astronomy, popularization of citizen science projects, All India Radio invited speaker. He's been an awardee in Global Kids Achievers Awards for the category of astronomy, silver honor in the International Astronomy and Astrophysics competitions. And I welcome Teja to talk to us about his journey.
Good evening, ma'am. Thank you very much, ma'am, for enabling me to talk here and share one of the important citizen science project, which I would like to share. That is the Galaxy Cruise by the National Astronomical Observatory of Japan, that is NAOJ. So I would like to share my screen and just a minute, please. I'm just making sure I share my screen and start my presentation. I hope you can see my screen.
All's good. We can see a desktop just now, but not your presentation.
Yeah. So I'll be sharing a link after I complete my talk about the Galaxy Cruise. So this is how basically the page looks like. So before getting into that, I just want to introduce what the citizen science project of Galaxy Cruise is. So it's basically an project where you'll be actually doing the galaxy morphology. So as most of you might already know what galaxy morphology is, that is the observing these galaxies and categorizing them into their types, such as we have spiral galaxy, we have elliptical galaxy, and I got to know much more about galaxies from Priya ma'am when I started the project, basically from the Pune Knowledge Cluster and from the Galaxy Cruise. I got to know much more about the galaxy morphology from Priya ma'am, Nazam sir, Sovan Acharya sir. So really great, very thank you for them for helping me to understand about galaxies and making me a part of the project. So once you basically register for your talk, for the project, you're going to get a slide like this. So you're going to log in with your particular email. So I'm just logging in with my email. A minute, please. Yeah. So you'll be getting an option like this. You can just do OK. And there are different kinds of campaigns for you. If you would like to participate in one particular campaign, so there are different campaigns for you, such as my latest campaign was from the August month's classifying 1,000 galaxies in 1 month. So that was the campaign in August. So there are many more such campaigns. But before that, what you need to understand is how exactly you're going to do this galaxy morphology. So you get something like this. So after this particular thing, you can just click on this wheel, the next galaxy once, and it takes you to another galaxy. So there are different types of galaxies, as you already know. There's also study material for you to understand about different types of galaxies. So you can see this particular galaxy here, but if you are unable to understand about it or see it properly, so you also have different types of settings. So you can just choose the dark mode, which really removes all the light, right? So this is much more clear now than what it was before. So I do not see any kind of spiral arms. So we basically have spiral arms for a spiral galaxy, but I do not see any spiral arms. But I just see this like an elliptical galaxy. You see, so you see the elliptical galaxy here, and it's very similar. So I just want to go with the option of elliptical galaxy. And I also see that I do not see any interaction. So there's no galaxy nearby which is interacting this, and let me go with not interacting. And I'm submitting my report for this particular galaxy. So yeah, so it states you whether you're correct or wrong, or how many areas are left. So this is how you basically do the galaxy cruise. But one important question arises of why exactly we're doing this. So I also have another a short presentation for this. Uh, yeah. So the story of Hani and mystery of Urva. So most of you might already know, but I just want to repeat it. So while classifying the galaxies online on August 3rd, 2007, a Dutch biology teacher, Hani van Arke, she discovered a new object from this particular project itself, the galaxy cruise from the National Astronomical Observatory of Japan. So she saw this particular galaxy IC 2497, and just below that she could see some green object which was quite mysterious. We do not see such objects; they're very rare, right? So she's seen something like that, and she just named it Urva. So she have mailed the experts, and she wanted to understand what exactly it was. So after mailing the experts, what she got an answer is that, so before that it was not known. Even the experts had to do some research, and they had to understand what it was. So once they did the research, they got to know that the spiral galaxy IC 2497 gravitationally interacts with the passing galaxy. So whenever the galaxies are getting collided, so this particular galaxy has interacted with the passing galaxy, and a large tidal tail of gas is basically pulled from the spiral galaxy. So two spiral galaxies are getting interacted, and a large tidal tail of this particular galaxy is pulled. And with engrossed with gas and black hole at the center, we all of you already know that most of the galaxies in the universe have black holes in the center. And it turns out that it is actually a quasar. So quasars, we actually say the complete galaxy or a particular object to be quasar. But why do we say that to be quasar is that there's a lot of light, and because of the huge amount of light, you do not see the galaxy. It's the same like the stars early in the morning. So there are stars, but you do not see that because of the sunlight. So it finally the final answer for that is that it's an portion of the spiral arm, and the gas streaming from the galaxy center impacts the tidal tail, And at this particular zone, we have the star formation. So what do we actually get from this story is that this discovery was made because of the participation in the citizen astronomy research, and the project that has a huge amount of data. So we can conclude that participating in citizen science projects helps you to be a contributor to real science and help you understand what exactly the particular object is. As A4 mentioned by Stella ma'am, that you don't need to have a degree, or you don't need to be really, you just have to have an excitement or just an interest that you actually want to learn. And you can see that the Dutch biology teacher has discovered a new object. It means a strange object. And so this particularly says us that participating in citizen science research projects really help you to contribute to real science. With this presentation, I would like to end my talk, because there's also a lot of members about to talk, and much more interesting projects are being shared by them. Uh, so, yes, ma'am.
Yeah. So thanks a lot, Teja. Thanks a lot. And we'll move to our next speaker, and we'll take all questions together after this, the six speakers, right? So I will move on. Thanks so much, Teja. Thank you very much. You'd be a source of inspiration for a lot of us. And let's move to our next speaker, Amoli, who's also a source of inspiration for many. And she's an avid astrophotographer, has also featured with AAVSO as an observer. She's taken part in several citizen science projects with discoveries to her credit. She's also trained students for IASC, which includes me. She didn't train me too. And welcome, Amoli, and we all look forward to hearing from you.
Yeah, good evening all. I'll just share my screen. Yeah, I hope you are able to see my screen.
Yes, all's good. All's good. You can go ahead.
So today I'm going to talk about a very interesting citizen science project, which is actually an individual project about interstellar dust. Now, what is actually interstellar dust? Whenever a comet passes through the night sky or through the celestial area, we see that it leaves about some dust particles or some remnants of its on the path where it goes from. So that particular particles can be collected on some aerogel or some aluminum foil by the spacecraft which was sent by NASA specifically to collect the dust particles, so that we could analyze what that comet or what is that interstellar dust all about, what is it made up of. So what we achieve is that we get a few images which are actually very small. They are about 20 microns, and we need to see them through the electron microscope. They cannot be seen through the normal microscope, that is the light microscope. Now, if in this image, if you see clearly, you can find this kind of a dot. Do you see it clearly? It has a white outer surface and an inner black area. This can be registered as a area where the interstellar dust particle has hit on the aluminum foil. Now, these are a few images which were taken by the virtual microscope, actually, not telescope, the virtual microscope. And these are the holes which were made on the foil by the interstellar dust. Now, these particles are really small, but their impact on the foil is quite large, as we can see here. Now, for this project, actually, what you need to do is you need to first log in on the, I'll share the link for the website, and then you need to go to the review tutorial through the review tutorial, you will get to know how to analyze each and every image. Now, there are different steps to analyze the images. Like this one is a very good image of the interstellar dust particle which has hit the aluminum foil. Similarly, now here we need to see the images very carefully so that we can exactly point out where the particle has hit. Now, if I just reduce the size of the image and if I just overlook it, I won't be able to point out on this spot where the interstellar dust particle has hit. And in fact, if you see this, this is just a small scratch on the aluminum foil. This is nothing related to the interstellar dust, right? Now, after going through the tutorial, what happens is the last part is that they will ask you to give a small test. That is, they will tell you to register and give a small test so that they know whether you have understood the concept of identifying the interstellar dust particle spots. So after clearing that, when you get the images like these, you get, this is the main page where you find your microscopic images of the aluminum foil. Now this is the image. If I even enhance it, if I zoom it also, I don't find any kind of spot here. So what I do is I click on no crater. Now, even in this kind of image, like if you see it here, this image, this part is also not a crater made by the interstellar dust. Why? Because it is just a point on the aluminum foil. This is the whenever there is a crater made by the interstellar dust particle, actually the particle hits very strongly on the aluminum foil. So it creates a great impact on the aluminum foil. It pierces through the aluminum foil, making a hole over there. So this is again not a crater. Not even in this. So this is how you can actually go through the project of interstellar dust particles. Now, if I zoom here, here what you find is the outer area is quite similar to a crater, but the inside part is not as dark as it should be. So we will not consider this as a probable crater. So I will say it as no crater. So this is how you can go about the analysis of these images. Now, how to see whether your analysis has been correct or not. Now, till now, my official status is indeterminate. That means this people who are actually taking this project on haven't checked my results. So when they check my result, they will just give me points on this, right? And this is the number of people who have viewed this image, which I had seen, and number of agreements. Like 109 people have viewed this particular image, and 10 people agree on what as I say, that this image has a crater. So this is the way we can put our data, we can analyze our data. Now, this is the first part about what we do in interstellar dust. Now, the second is how to, one of the participants has asked about the questions on how to be a part of the sun entry or how to evaluate the sunspots. So for that, what we do is we go to the AAVSO webpage. Here we find that First of all, we need to request for the observer code over here. This observer code will create an account of yourself. When you create your account, you will get an observer code. Like for me, it is KAMB. That is my observer code. And whenever I upload any observation of mine, it will be registered in the name of KAMB. After that, when you have your observer code, what you need to do is, like for the sun entry, you first of all need a Java base on your laptop or your computer. Next is you need to do the sun entry part. Now, doing the sun entry part is that you are observing sunspots on a daily basis through your telescope and registering them and organizing them in a table format and showing it and uploading it on the AAVSO site. So these are the steps to be followed while doing the sun entry part. Now, if I show you how is it done, I'll just show how the entry is done.
Yeah, Amoli.
Okay. Yeah. Now, here what I see is there is a small table which appears. Here I put the day, that is, suppose today is 3rd of December. Whatever time I observe my sun, that is, I observe my sun as about 10 o'clock and 30 minutes. What are the seeing conditions? Are they excellent? Are they good? Are they fair or are they poor? Suppose my seeing conditions are good. And now the number of groups. Now, how will you see that what are the number of groups that are being, just a second. Okay. Now here, if you see this is the image taken by me using the telescope and my phone camera.
Amoli ma'am, excuse me, ma'am, we are only able to see the original scene which you have shared regarding AAVSO sun entry.
Okay.
Yeah, you need to move it or.
Are you able to see this? The
Amoli ji, you have to share your entire screen. What's happening is you have shared only the web page. You have to share the entire screen.
Okay. Entire screen.
Just say share desktop, then you'll get everything.
Click on share screen. Don't go on presentation or any specific thing.
Are you able to
Yes,
see it
yes. Now we are.
Perfect, ma'am.
Yeah. Now this is the sun entry table where I put my sun entry. This is the month, the year, the day on which I had clicked my image, at the time at which I had clicked, the seeing conditions, and now the number of groups. Now, how will I check that? I'll just show you. Now, if you see in this image, you see there are 3 spots, 1, 2, and 3. Now, the sun can be divided again in the northern hemisphere and the southern hemisphere. See, in the northern hemisphere, I am seeing 2 sunspots. That means they are 2. Here, this spot and this spot are 2 different groups because they are not very close to each other. So I consider them as different groups. So there are 3 groups of sunspots, each having different number of sunspots. Each group might have a number of sunspots in them, right? So there are 3 groups in all, and each group will be having different number of sunspots. So this group is having one, this group is having one, and here I see there are two spots, right? So now what should be my sun entry? Sorry. Where is it? Okay, I'll do it again. Just a sec. Yeah. Now, the date is suppose 3rd, R is suppose 10 o'clock, 30 minutes. Sorry. What is this? Ten, 30. Seeing conditions are good. Number of groups which I saw was 3. Number of spots in total were 4. 1, 2, 3, 4. And then I click on remarks. As and when I click on remarks, the area called wolf gets activated. It has some data in it. And then I click on add. When I click on add, I see a observation line over here. Now this is, what is this? NG. NG means north group. The group number of groups present in the northern hemisphere of the sun. That was 2. Number of groups present in the southern hemisphere. That was 1. Number of spots present in the northern hemisphere. That were 2. And number of spots present in the southern spot were 2. So this is the way I do my entry. So this is the entry for 3rd of December. Now, when I click the photograph again tomorrow, I'll again mention it as day 4, time, hour, and this way I can continue. I save the file, and at the end of the month, what I do is I click on upload to database. And as and when I upload to database, what happens is it sends my observation by the name of KAMB to AAVSO, where they publish a news bulletin every fortnight, every monthly, in the middle of the month, around 15th or 16th of every month, where you can find your findings registered. So this is all about the sun entry project of the AAVSO. I haven't done the variable star astronomy, which Stella ma'am had been talking about. I would definitely like to do and learn about it more. So next time, whenever we meet, we can talk about it.
Thanks so much, Amoli, for describing 2 excellent projects. And the best part is of this, all of them are so very different and so very interesting. So thanks a lot, but I will move ahead.
Yeah,
We
sure.
have another interesting talk now by Shubham. Shubham is actually a student of mechanical engineering from Chandigarh University, and he's involved in student nano satellites under KUSAT, which was launched by ISRO in 2022. Also on solar panels used on nano satellites for astronomical purpose, solid rocket propulsion under Chandigarh University. And as a citizen scientist, he's also been working with the core team at the Disk Detective Project, GAVRT, and Spectropolis. So, welcome, Shubham. We all look forward to hearing from you.
Shubham, you are muted.
No, it's my, I made
Hello.
him post.
I'm
Now he'll be fine. Yeah. And now you'll be able to share also.
Thank you.
Sorry, I had missed your thing.
So the screen is visible, ma'am.
Yeah, great. Now just go on slideshare mode. Perfect. You can
Yeah.
go ahead.
So today I'm going to present two of the major interesting projects. One is by like both of the projects are by NASA. One is Disk Detective Project, and second is Gravity Spy, which is by LIGO. So the first project is Disk Detective Project. As we know that we are always like curious to know how our solar system is formed. So the thing is, there is one project that is Disk Detective Project. The main aim of the project is to find the to solve the mystery of the you can say how a solar system is formed within our universe also, and outside of the galaxy, and you can say outside of the solar system, our solar system also. So this project is basically the telescope used in this project is NASA WISE mission, WISE telescope. So basically it's an infrared telescope. Okay, so we are using this telescope by just taking an infrared image, and we use the platform that is Zone Universe. We will get the live data from the NASA. So can you imagine that this project has discovered 2 million, more than 2 million object in which they have discovered the galaxies, nebulae, and other dust materials also, and there are some artifacts also which are which you can say some distortions. So the what as I already told that we in this project we have to classify the disk that is YSO, that's a nickname. The full form of YSO is young stellar object. So the thing is, here we are using the wiser data. Okay, so by using wiser data we can classify the things. So here I have added one GIF that is showing a potential candidate of you can say for being a for being a potential candidate where we can find a solar system. We can find a newly born planets. So the beauty of the project is firstly we have to register ourselves in a platform that is a live platform, global platform, that is Zone Universe. So I will show. Can you see the screen of I have opened a browser? Can anyone can confirm?
Yes, we can see. All's fine.
Okay, ma'am. So this is I have opened an interface of Zone Universe.
No.
In
We
that.
can't see that. We can just see your PPT. We can see your PPT.
Okay.
I can't see your Zoo Universe page. Yeah.
Okay, wait now. Can you see now? I have opened a browser.
Now I can see the unwise. Yeah.
Yeah. Okay. So I have opened a disk detective project under the Zone Universe website by using the Zone Universe website. So this as I already told that you have to classify the potential candidate. So how to classify potential candidate? Here we are using different kind of infrared images. So the concept is we have total 8 to 7 images, which will include wise data, unwise data, pan-star images. So according to that, we have to classify how there are two circles. In that we have to see that the center image remain in the two of the circle, not get distorted. So as you can see, in a first image the star is in the circle, then in the second also the star is in the circle, then in third, then in fourth, then in fifth, then in sixth, same. Okay, so now you can observe that the image, the star is going to be little bit blurred. Okay, and going little bit out of the circle. So the next image, you can see again there is some changes. This is because of the saturation of the image. The star near to this this YS, or like you can say any star object, like any star, this nearby object creating some saturation effect. Okay, so in the next image you can see the image get distorted, so it's not a good candidate. Okay, so for a good candidate, what we have to see, like you can see here, I will show. So as you can see here in this GIF, the object which is present in the center is never going outside these two circles. Okay, so it's like a potential, it's like a, you can say it's like a eligibility criteria for any object. Okay, so the benefit of this project is, if you classify more than 700 objects, okay, whether it's potential or not, the experts are present at the Zuno Universe platform. They will correct you. But if you classify more than 700 disk detective objects, then after that you have to write one mail to the disk detective, to the, like you can say, head of the disk detective project director. So he will redirect you to the main team of the project. As I have classified more than thousand of the disk detective, and now I am working as a citizen scientist with the disk detective project in a core team. So the next thing is, like, this is an interface of the project. Okay, so here we have different kind of thing, like the object is moving in a crosshair, then the object is round or not, it's extended. If you find any of the defect, you have to mark that, and later you have to click on submit button. But if you didn't find any kind of defect, that means you have find a potential candidate. For that, what you can do, let me show. So below here, like I have find there one defect. Okay, the object is unwise and little bit extended. Okay, so if you want to click on done, then you can click on done. But if you find something new in this object, then you have to click on done and talk. Okay, after clicking done and talk, you have to post your comments by using some hashtag or whatever you have find there. Like if you find something a good potential candidate, you have to mention that it's a good potential candidate. After selecting into the main team, you will get an opportunity to explore more. Okay, so in that there is one I button. Here you will get all the data, original data, like you will redirect to the you can say to the Visor website, then Simbad website, then Visor you are like there you will get the Gaia data and some other data to plot and photometry out. So on the behalf of that, you can like explore deeper into it. So the next project is Gravity Spy. I love this project because like I'm very much interested in black hole, then neutron stars. So this project is dedicated to the black hole and neutron stars. So basically, Gravity Spy or LIGO is basically based on Michelson-Morley project experiment. So here is what happened, like where there we have a set of mirror, then reflective mirrors also. So by that, what happened when we put the laser on the mirror, it divided into two parts, and after that it back again, it come back again. And by this experiment, we get to know that the speed of light is constant. So by using the principle of you can say like the Michelson-Morley experiment, LIGO was like LIGO laboratory was set up. So in 2015, by using LIGO, we have discovered first you can say like black hole merge. So we get the signal, you can see here in a first in the image 3, the signal is named as blip. So sorry, the signal is named as chirp. So why it's named as chirp? Because when you listen the sound of two black hole merge, they have found the frequency and they name just it as a chirp. So there are number of signals like glitches, you can say, like blip, then frequency of 1080 hertz. There are number of frequencies. So on the base, but we have certain range of frequency. On behalf of that, by using Python and machine learning, we find that the frequency ranges from 332 hertz to 500 512 is basically for the, you can say, a black hole merge. So very sensitive. It's very sensitive. So the, like, in 2015, the first black hole merge was discovered, but in recently, in on 5 January and 15 January, there are two. One is black hole neutron merge was discovered, and on 15th January, black hole merge was discovered. So this project is really interesting for me because this project is just like a game. So in that, what we have, again, we have to go to the, what I will say, to the Zone Universe platform. So in that, we just have to move. Wait. So this is an interface of Gravity Spy. So at present, I am level 9. So this project is basically divided into 10 level. Level is like, firstly, you have to just classify the, you will say, normal signals. Then after that, at level 9, you will be a citizen scientist to classify the signals of black hole merge. So like, if you have any problem, like if you are not able to get what this signal represent and how you get the information about this, so for that there is one field guide. So in that, you will get all the information regarding every signal. For example, I have talked about chirp. Okay, so the black hole, which show the black hole merge. So the signal is just like this. Okay, so you will find a exponential curve type. So here again, when you see the signal, like it's looking like an blip also. Okay, so here we can see there is one chip, then there is one glitch which is known as blip. Okay, this glitch, the glitch is known as blip. It's look like both, but the thing is, the concept was like, if you see the chip, so so here the thing is, like, if you go to the animation mode, the signal look like something this, moving the image frame by frame. Okay, so what you have to do, there are different kind of options available here. So on the basis of what kind of image you have find, you have to classify the image. For example, according to me, it's chip, then identify. Then if you want to, like, if you want to discuss something about this object, you can just done and talk. If you do not want to, like, and do any kind of discussion, just done. So you can find an interface. If your classification match with your, like, you can say, some experts classification, you will get the interface like this. Your response chip, when our expert classify this image, they label it as light modulation. Okay, it's also look similar to the glitch. So the thing is, you will get the classification notifications also, like if you're doing the classification right or not wrong. So this is all about the what I will say, the Gravity Spy. And if you want to go deeper into the Gravity Spy, the Gravity Spy, there is one website that is a Gravity Pi something. Okay, Gravity Pi. So here you will, like, if you are advanced in Python and machine learning, you can visit that website, And by using the citizen science data, you can plot all these kind of stuff which I am showing to you. So if you want to like dive into deeper, so just explore the website, and I will put the link of the website into the chat box. Thanks so much.
Thanks so much, Shubham, for a lovely talk and for very interesting projects. I'm sorry, but we'll run ahead. We'll move ahead to Ashok sir. Ashok sir has been a member of the Skywatchers Association, Calcutta, as well as of Sovan Acharya Citizen Science Group. He's a central government employee of the Indian Railway, but he's basically a theatre actor, a social worker, and also a citizen scientist. And he's a member of the Skywatchers Association, Calcutta, and he's participated in many projects under Zoo Universe and ISC. So welcome, Sovan sir, and you can share your screen. Yeah. Yes, sir. So you could share your screen and.
Ashok sir, you are muted. Kindly
Yeah.
unmute yourself.
Yeah. Yeah. Meanwhile, I'd like to request the participants to add on your questions in the chat window, and we'll take them all in the end. Most of them, there are already so many questions. Ashok sir, all fine, or you need help?
I think there is some problem with the mic of Ashok sir, ma'am, because
Yeah.
Yes.
I
He has to change the audio settings. Maybe. Amit,
Ashok sir, we cannot. Okay, I'm telling him ask to unmute. It's not coming. I can't do it.
and now Ashok sir is unmuted. Ashok sir, kindly speak.
Yeah, you can start talking, sir.
Can you hear me?
Yes, perfect. We can hear you.
But I can't see the tab of.
So there's a green tab down which says share screen. It's green. In the center, you'll see share screen. It's green in color, and you can click that.
No, I didn't see it.
Do you see any of the icons below, like mute, start video,
No.
security?
अभी तो था इतना सारा चीज था लेकिन अचानक कहाँ चला गया?
Yes, yes. So look in the more if you have, or maybe it's just gone behind somewhere.
हाँ, अभी तक था सारा.
Like Kiran Kumar sir points out, look at the Zoom window, not the PowerPoint. You're looking at the Zoom window, right?
Okay.
Zoom window में देखिए आपको, you'll find mute, stop video, security, and the green one is share screen. Green button. Zoom में जाइए. Go to the Zoom.
Zoom में मैं हूँ, लेकिन वहाँ कुछ नहीं लग रहा है. शुभम जी जब बोल रहे थे तो सारा चीज मैं देख रहा था, लेकिन अचानक वो रखने के बाद ये सारा चीज गायब हो गया कहाँ से. यही मुश्किल है. तो ये भी मैं बताना चाहूंगा, जो भी हो, देखिए एक प्रॉब्लम हो रहा है, मैं इसको आगे हैंडल नहीं कर पा रहा हूँ। तो ये मैं धन्यवाद प्रिया जी, मैं स्टार्ट करता हूँ इसलिए कि समय बीता जा रहा है। तो मैं सबको यही चीज बताना चाहता हूँ कि देखिए, यूनिवर्स में जो काम करना चाहते हैं उनके लिए, खास करके जो नए हैं उनके लिए हम ये बोलना चाहते हैं कि जो यूनिवर्स में काम करना चाहते हैं, यानी जिसका दिल में या मन में स्पेस के प्रति या यूनिवर्स के प्रति एक प्यार है, आकर्षण है, जो जानना चाहते हैं यूनिवर्स के अंदर में क्या है, क्या खेल चल रहा है अंदर में, और ये इतना बड़ा चीज है कि आप जानते जानते आप इसमें विभोर हो जाइएगा, लेकिन आपको ये आनंद मिलना कभी बंद नहीं होगा। ये ऐसा एक चीज है। लेकिन ये मैं खुद एक कॉमर्स का स्टूडेंट हूँ, लेकिन मुझे ऐसा लगता था कि क्या मैं इतना ये जो ब्रह्मांड है इसके बारे में जो खोज चलता है, जो हमको पेपर से मालूम चलता है या कोई किताब पढ़ के मालूम चलता है, ये इस टाइप का कुछ काम क्या मैं भी कर सकता हूँ ऐसा, या ये इस टाइप का काम करने का ख्वाहिश मेरा मन के अंदर बहुत था। लेकिन अपना दूसरे कामों से मैं बहुत बिजी रहता हूँ, और स्पेस के ऊपर काम करने के लिए या ऐसा एसोसिएशन मिलने के लिए उपाय नहीं था, हमको बहुत देर से मिला ऐसा एसोसिएशन, जो स्काई वॉचर्स एसोसिएशन है कलकत्ता में। हमको वहाँ उन लोगों के साथ मेरा जो जोगाजोग हुआ वो कुछ साल पहले हुआ। तो उसके बाद धीरे धीरे मैं इसमें इसके और आने लगा, और शोभन सर के उनके साथ बात करने के बाद मुझे ऐसा लगा कि मैं कॉमर्स के स्टूडेंट हूँ, लेकिन मेरा दिल में एक इच्छा है स्पेस लेके अगर मैं कुछ काम कर सकता हूँ, अगर कुछ कंट्रीब्यूट कर सकता हूँ। ये उन्होंने हमको बताया कि हाँ हम ये कर सकते हैं। तो ये चीज हम इसलिए बोल रहे हैं कि आप लोगों में जो नए हैं, जो छोटे हैं, या जो स्पेस और ब्रह्मांड लेके काम करना चाहते हैं, बहुत कुछ अंदर में छुपा हुआ है, बहुत सुपरनोवा है, बहुत स्टार्स हैं, बहुत ब्लैक होल्स हैं, मंगल ग्रह हैं, उसके ऊपर मैपिंग का काम हो सकता है, डार्क एनर्जी लेके आप काम कर सकते हैं, आप ब्लैक होल का जो सिग्नल है उसको लोकेट कर सकते हैं, उसको मार्क कर सकते हैं। तो इस तरह से आप बहुत तरह से यूनिवर्स साइट के थ्रू आप बहुत सुंदर काम कर सकते हैं स्पेस में, यानी स्पेस के लिए। और ये चीज मुझे बहुत आनंद देता है कि मुझसे भी ये चीज हो रहा है। तो हम इसलिए बात कहना चाहते हैं कि आप लोगों में, जो लोगों का अंदर में मन में दुविधा है कि यूनिवर्स एक साइड से तो बहुत बड़ा कुछ होगा, हाँ बहुत सख्त कुछ होगा, ऐसा बात नहीं है। अगर आपके अंदर में दिल में जोश है और मन के अंदर इच्छा है और प्यार है ब्रह्मांड को लेके, उसको जानने के लिए, उसके अंदर में क्या है इसको निकालने का अगर ख्वाहिश है मन में, तो आप लग पड़िए, आप सकिएगा, जरूर सकिएगा। और ये बहुत आसान, ये पूरा यूनिवर्स जो टीम है वो बहुत ही अच्छा प्रोग्राम के क्रिएट किए हैं, जिसके लिए बहुत अलग अलग कामों के लिए अलग अलग प्रोग्राम उन्होंने इस तरह से उन्होंने बनाया है कि उसको बहुत आसान तरीके से कोई भी नागरिक, वो कुछ भी हो, स्टेला मैम बोल रहे थे कि आप नर्स हो, आप इंजीनियर हो, इस तरह से वो बोल रहे थे, ठीक वही बात मैं भी कहना चाहता हूँ कि आप कुछ बाय प्रोफेशन आप कुछ भी हो, लेकिन आप ये काम कर सकते हैं अगर आपका मन का ख्वाहिश है। यूनिवर्स इस तरह से प्रोग्राम को बनाता है कि आप जो चीज निकालने के लिए बहुत सारा प्रोजेक्ट होते हैं यूनिवर्स के ऊपर, उसमें से आपको जो मन करता है उसके बारे में आप, उसमें ट्यूटोरियल है, उसको पढ़ सकते हैं, बहुत आसान तरीके से वो लिखा रहता है, और उसमें एक फील्ड गाइड होता है, वो भी आप पढ़ सकते हैं, उसमें एग्जाम्पल दिया रहता है, वो देख देख के आप धीरे धीरे सारा चीज समझ जाएंगे और आप काम जब करना शुरू करेंगे तो आपको लगेगा कि आप काम कर पा रहे हैं और यूनिवर्स का जो सर्चिंग चल रहा है अंदर में क्या है ये जानने के लिए सारी दुनिया में जो पहले हम लोग सोचते थे ये काम सिर्फ नासा के जो साइंटिस्ट है या यूरोपियन एजेंसी के जो साइंटिस्ट है, बड़े बड़े विज्ञानी है, इंजीनियर है, यही लोग करते हैं, ऐसा बात नहीं है। इतना सारे तत्व, इतने सारे डेटा अभी गैदर हो रहा है कि ये संभव नहीं है कि एक सुपर कंप्यूटर इसको सब कुछ निकाले। एक ह्यूमन माइंड का जरूरत होता है और इसीलिए दुनिया भर में जो भी सिटीजन साइंटिस्ट है जो स्पेस में रुचि रखते हैं और इंटरेस्ट रखते हैं, उनके लिए ये यूनिवर्स की तरह जो साइट है उनमें ये सारे डाटा बहुत 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 आसान तरीके से इसके अंदर में थोपा गया है और उसको देख देख के आप बहुत सारे काम कर सकते हैं। तो यही मेरा आप लोगों को कहना चाहता हूं कि मैं पिछले 2 साल से 2 साल पहले हम इसके बारे में कुछ नहीं जानते थे, लेकिन 2 साल पहले हम कोरोना पीरियड में जब स्टार्ट हुआ तो उसी समय इसके बारे में हमको पता चला और ये काम करते करते हम देखे सुपरनोवा जब हंटिंग करने लगे तो अचानक मेरा नाम हम देखे तो उनका साइट में मेरा नाम आ गया। तो ये मुझे बहुत आनंद दिया कि हम ये कर सकते हैं। हम आश्चर्य रह गए कि ये हम कर सकते हैं, ये यानी हम ठीक काम किए हैं, इसलिए हम ये नाम आया है। तो हम बहुत ही जोर शोर से इसके पीछे लग गए। तो हम उस समय तो हम लोगों का बहुत सोशल वर्क हो रहा था सारा दिन कोरोना के लिए, लेकिन हम रात में काम करते थे 12 बजे के बाद। लेकिन और ऐसा होता है कि 4 बज रहा है लेकिन नींद नहीं आ रहा है, ऐसा अच्छा लग रहा है। और 1 साल के अंदर 1000 सुपरनोवा डिस्कवरी में मेरा नाम आ गया। तो ये सारा जो क्रेडिट है ये बहुत बड़ा श्रेय जाता है सोवन सर का, उन्होंने हमको काफी उत्साहित किया है। तो ये चीज आप लोगों भी कर सकते हैं। तो हमको लगता है आप लोगों में जो ये यूनिवर्स के बहुत सारे प्रोजेक्ट हैं, इवन ब्लैक होल का ऊपर भी एक प्रोजेक्ट आया है जो बहुत ही इंटरेस्टिंग है। ब्लैक होल का जो आपके सिग्नल पीक सिग्नल है उसको आपके निकालना पड़ता है। अगर आप उसको डिनोट कीजिएगा ठीक तरीके से तो आप भी एक कंट्रीब्यूट कर सकिएगा ब्लैक होल निकालने में। तो इस तरह से बहुत सारा का काम है, लेकिन हमको लगता है कि आप पहला काम अगर सुपरनोवा हंटिंग से स्टार्ट कीजिएगा तो शायद आपके लिए बहुत ये आसान होगा और बहुत एनकरेजिंग होगा। तो लग पड़िए, जो नए लोग हैं आप सामने आइए, बेझिझक आप इस जो बिल्कुल असीम इनफाइनिट जो दुनिया है उसमें आप घुस बैठिए और एक के बाद एक डिस्कवरी करते जाइए करते जाइए करते जाइए। और इसमें अगर आपको आनंद मिलेगा तो आपको क्या बताऊं, एक बहुत अच्छा सुकून मिलेगा, बहुत अच्छा आपको फीलिंग होगा। और जो हमारा ये जो परिवार है सिटीजन साइंटिस्ट का, ये जो परिवार है जो जिससे परिवार काफी बड़ा हो चुका है, तो ये परिवार भी बहुत अच्छा है। यहाँ बहुत सारे अच्छे अच्छे आदमी हैं और आपको कोई भी हेल्प अगर कहीं आप कुछ फंस जाए यानी कुछ चीज समझ में ना आए तो आप पूछ सकते हैं ग्रुप में, आपका प्रश्न कर सकते हैं, आपको उत्तर मिल जाएगा। तो आपको कोई असुविधा नहीं है। सिर्फ एक ही चीज लगेगा, आपका दिल का इच्छा लगेगा, ईगरनेस लगेगा, ईगरनेस ऑफ माइंड टू डिस्कवर यूनिवर्स। उसका अंदर का जो बात है उसको हम जानना चाहते हैं, खोजना चाहते हैं। यही चीज अगर आपका माइंड में रहेगा तो आप बहुत कुछ कर पाइएगा यूनिवर्स को यूज करके। बस हमको यही बोलना है। ऑल द बेस्ट। आप सभी को मेरा श्रद्धा और प्यार।
थैंक यू वेरी मच अशोक सर, आपने बहुत ही खूबसूरती से वही बात की जो हम लोग करना चाह रहे थे कि अगर आप साइंस बैकग्राउंड के भी नहीं हैं, अगर आपको इच्छा है, इंटरेस्ट है, तो दैट्स ऑल दैट्स रिक्वायर्ड, राइट? So I will
Exactly.
repeat what Ashok sir said, very inspiring this thing, where you don't have to be a science student, a science background student. There is so much that you can do in studying the universe, even if you do not have a science background. And sir
Exactly.
has mentioned that it can give you a lot of pleasure. You can actually do something which is very worthwhile for the astronomy community, and hence this open invitation is there for everybody to join.
Right.
So thank you very much, Ashok sir.
Thank you, everybody. Thank you, Priya ma'am.
Yeah, thank you. We'll move on to the next speaker, who's Sovan Acharya, who has been the inspiration for a lot of the people who have been talking on our episodes, on our different webinars. And Sovan Acharya sir was basically a civil engineer. He worked in L&T, but astronomy has been his hobby. And he has participated in various science projects. And here we have him. And sir, I need to mute.
Sovan sir, you are muted.
Sovan sir, you need to unmute yourself. And I'll continue with my introduction to Sovan sir. Like I said, he's been inspiration for all of the participants we have over here. He's been active in astronomy. There's a WhatsApp group called Sovan Acharya Citizen Science Group. A lot of us are members of that. You can join that. That will keep you updated on how to know of new projects. He works as BINU mappers, provisional asteroids, preliminary detections also. As a citizen science, he's been active in the detection of supernovas, TNOs, exoplanet candidates and tests, and a team member of the Planet Patrol project. So welcome, Sovan sir, and we all look forward to hearing from you. Yeah. Please put it on slideshow mode.
Okay. Good evening to all. Say a lot of scope is there. So I say anyone can participate and use as a hobby and learn. That's all. Over to ma'am.
Yes, sir.
Over to you.
So you want to say something more? There's a lot of.
Ma'am, I think there is some bandwidth as well as network issue with Sovan sir. His bandwidth is low.
Okay. Okay. Then we'll move to. Then should I move to the next speaker or?
Yes.
Yeah. So we have our final speaker now, Amit Raka, who spoke to us last time too, and he's by profession an educator, by qualification a businessman, and by interest an amateur astronomer. Last session he spoke to us about astrophotography. And this time he's going to talk to us about some of the Zoo Universe projects. So welcome, Amit. Sovan sir, do you still want to talk or?
Carry on, sir.
Okay, sir. Thank you. Yeah. So, Amit, you can.
Yes. Thank you. I hope you are able to see my screen. I have shared it on
yes.
slideshow also. Okay.
Perfect. It's all good.
That's very good. I'll be first talking about very good evening and namaste to everyone. I'll be talking about some of the achievements that I have made in Zooniverse platform in previous 1 year. This was one of the greatest breakthrough for me, as everyone is sharing. You must go for supernova. Definitely go for supernova discoveries. And the project, it is fabulous because you become a part of a discovery, and your name is being listed on the website. So that gives you a different kind of feeling, and that is amazing. In the first year itself, I have discovered almost 400 plus supernovas, out of which almost 106 are certified. So they are on TNS server. So 106 certificates of supernova are being registered with TNS server with one of my name over there. So this is really very inspiration, especially for the non-technical background students. As one of our group member Ashok sir also said, he is from commerce background. The same way I am also from the commerce background, and really has, like, since childhood I has an interest in astronomy, nature and everything. So this pulled me out in this field. Few of my achievement of earth sky, one of moon and crescent moon and Mercury was featured. Moon occultation with Mars occultation with moon, sorry, that also was featured. Some sunspot, moon halo, some of like recently one of the biggest meteoroid that I have captured with the mobile was been also featured on in Times of India. One of my student who is constantly being a part of IASC program, and he is one of the first members, 6th grade student, the youngest astronomer we can say. So that was also a very great achievement for me. And yes, Moon Over Us is also one of the platform where I spoke about mobile astrophotography. And even on this platform recently, the previous session was on that also. Yes, Galaxy Cruise, as Teja also spoke about it. So this is also one of the good platform. Actually, my first comment after looking to that platform was to Sovan sir, is it a game or is it a research work? This was how, like, my comment I remember very clearly to Sovan sir, because it was so simple, it was so graphically designed and in such a way that it seemed that it is a game. So Zooniverse or the citizen scientist projects are made in so simplistic way that even a layman can understand what they have to do. What matters is just your interest. So that is how I started, and even I have enlisted my name on Galaxy Cruise. So that is a very good achievement again. And keep exploring about the new sciences. I'll shift towards the program, the citizen scientist projects actually. Okay, so the first project we will be talking about is active asteroid. So this is also again on the Zooniverse platform. So you have to go and register on it. But this is why this is the simplest one is only two reasons. One of the two reasons I would say. There are many other reasons, but these are the one of the two reasons why active asteroid program is being carried out over there. First is, where did water on Earth come from? This is their first question. And the second question is, where else can we find water in our solar system? So for these two reasons, active asteroid is being carried out. I'll directly jump to the website. I'll show you how does the platform looks like. So this is how the active asteroid will look like. Here you can see in the center, this is actually the frame which you have to analyze. This you can either zoom it in, out if you require. Here you can see there are green lines, diagonal lines, the perpendicular lines. So in between this, your object is placed. So you have to see only the object in the center of this green lines. So here I can very clearly see an object with a tail. So this is an active asteroid. So here you have to simply click on yes. And if you see some bizarre object apart from that, you can go and talk about it in the community, or simply click on done. And as you will click on done, there will be a congratulations message where it will show you that, okay, this was a right object or not. So even you will get instantly the reply of it. It is so simple. It is one of the most simplest project to be done with. Again, I can see over here, there is a tail to the object. So I'll again go and click on yes. And fortunately, I got consecutively 2 asteroids, active asteroid. That was amazing. Oh, here got again. Okay, this is again, here you can see the fuzziness. Anything, if you see an object in the center of it with a fuzziness around it, it is an asteroid. But provided none of the object other than that must have that fuzziness, because in some frames you will find all of the object having fuzziness. That is due to something known as bad image or defocused image. And for reference, you can always refer to field guide whenever you find it difficult, or you're not understanding what exactly we have to look, or what I'm looking at right now. You can go and look upon it, and it will guide you, is it right or wrong. And suppose I'm clicking yes on it, so again it is an asteroid, an active asteroid. So this is how you have to deal with it. Now here you can clearly see this is not an active asteroid. I don't see any fuzziness. I don't see any tail to this object. So I'll go and simply click on no. done. This is how simple an active asteroid project is. Go ahead, work for it, do whatever you want in Zooniverse project. There are n number of projects. I'll go to the second project, which is a bit technical, I would say, but again, it is not so much hard or difficult to understand. Only thing is you need to understand is this is the CERN. This is a new particle search by CERN. So it is the data is provided by CERN. This is the biggest hydro collider in Geneva. So definitely these research are only carried out by the physicists, the most expert people out there. But fortunately, because of Citizen Scientist Project, we are able to access to these kind of data that are being provided by the researchers, and it literally feels like a game, nothing less than a game. You will feel whenever you will be interacting with these kind of projects. This is how the new particle search at CERN looks like. Very simple. Two things in the frame you have to look upon. This is actually the frame which we have to look upon. So this is the transversal view of the photograph, and this is the longitudinal view. Here they have clearly mentioned what we have to search is we have to find the displaced vertices. Now, in simple terms, what do you mean by that is you have to find out the center of the origin of any particles that are displaced their positions. So here what you have to do is you have to click and you have to zoom in, because to understand are they going to meet up or not, this is one thing you need to understand. Here I can make a guess that this green line and pink line will meet at this particular point. They might meet. So this is where the two particles have collided and they have released the particles. So this is how we do, in the CERN, this is how they collide particle and look for new particles around. Second thing is go for the longitudinal view also. Over here also I can see the green and pink one may merge or may meet at this particular point, or over here I would say rather. Okay, and I'll click on done. Here you can see displaced vertices found, 2 matches. So there were only 2 vertices been meet, and both of them we have correctly identified it. It is so simple. I'm not going into technicalities right now. Where do we get this data from, and what does these data means to us? Right now you need to go and start for it. Slowly, steadily you will understand what this really means, because it have taken many decades to find out a new particle. So this is a very patientful job you have to do consistently. That's it. Don't look for results, at least in CERN. In this project it will take a long time. Now this seems to be a bit difficult one. You can see okay, so what we will do is, it seems they will merge out somewhere over here in longitudinal, and in transversal again we have to, sometimes you can even use your ruler. I do use sometimes ruler when the objects are really very far apart. You can simply place the ruler on your screen and you can make a guess, okay, where they will meet up, where they can meet. So I'll just place 2 points over here, because it seems green might also hit over here, and the brown one, light brown, and the orange one might meet over here. But there are only 2 vertices, we know very well. Okay, yes, I have missed one. Okay, so here you can very clearly see one vertices was very rightly done, and the second one we missed it by a bit, like by a fraction of that. So this is how you have to do it. So simple. If you have any doubt, again you can go on field guide, you can refer over here what kind of identifications we have to do. They have provided all kind of supports. Still, if you want, as a citizen scientist group definitely is there for you. You can ask your question, put up your question, and we are always there for you. I'd like to conclude with one more thing. There is also one more project known as Hubble Asteroid Hunters. So this is also very similar to active asteroid, so not very different. You can also participate in this, because this is very rarely this things appears. Lastly, I will conclude this with one thing. Utmost important is, today this session was all about space. the Universe platform is really an online research program wherein you can find out n number of categories, but of which we have spoken only a bit of space. Even there are more projects apart from this. You can see there are more projects. And apart from space, there are art, biology, climate, history, language, literature, medicine, nature, physics, and social science also. So you can explore any field you want. Go ahead, take your interest, but do participate in these projects because these are real-time projects and you are participating in real-time data in the research work and you will be helping them. And I would like to thank Priya ma'am and all the speakers of the today, especially our special guest Stella ma'am and all the speakers. Nevertheless, not less, the guest, the participants who have actually made our session successful and they have patiently waited for a long time because we took a bit of more time today. And thank you guys. Thank you very much. I hope everyone have enjoyed and you can go ahead for any questions if you have.
Yeah. So thanks a lot. Thanks, Amit, for the talk. I think we had some really nice talks, but we have totally overshot. We've like doubled our time.
Yes, yes.
So, I think we should take the questions. Please join the WhatsApp group that's there, and then you can interact because there'll not be one question, but many more. I would also like to bring your attention to a solar eclipse that's taking place tomorrow, but unfortunately not visible from India. It's in countries like Africa, Australia, South America, and the Atlantic, where they'll actually see this. But there would be many websites on the net through which you can actually see live streaming. So I'm sure if you Google around, you will actually find that and you can have a look at it. You'll see pictures in the papers. And I'm sorry, but I think we be forced to avoid questions. Yeah. The link of the WhatsApp group, I'll share it. Can someone please share the WhatsApp group link? And because we hope that this interaction continues, right? So Amritanshu, if you could share the WhatsApp link.
Amit sir or Sovan sir may be having. Amit sir, do you have the link?
Yeah, I'll just.
Okay, give me a second. I'll take it.
Yeah. Okay. So I'm sorry we are winding up. So I mean, but we are already double the time. So let's this thing. Thank you so much for joining us. And next Friday we're going to have another interesting session. That's going to be the moon over us. We'll have Moni Thurber who'll talk to us about it, as well as the Indian teams who've been participating with it. And I'm sure that's also going to be a very interesting session just on the moon. And we look forward to seeing you all for that session.
Number, share number, WhatsApp number.
Yeah. I think
Shubham, you can share your WhatsApp number.
WhatsApp number.
Yeah,
After that, they will contact you.
Yes,
Yeah.
This is WhatsApp number of Sovan sir. They can directly contact you. So kindly the participants who are interested, they can note down. I have mentioned the WhatsApp number.
Yeah. And in the next email, I'll send the WhatsApp link also. So you'll anyway get it. So don't worry. So thank you very much. Thanks everyone. And see you next Friday again. Bye-bye. See you. Bye.